Welcome to this question number one. We are trying to solve uh, methanol water distillation column. That means we want to separate methanol and water. So already here I have built a distillation column using shortcut distillation. Here you find the right side of the palette under the column you find shortcut here. I have chosen the shortcut and I built this flow sheet for you. Okay, what are the inputs I have given or mentioned in this question? So first, if you can see this, yeah, so let me maximize this so that you can actually see this properly. Oh, yeah, let me keep it straight. Yeah, so what is happening here, I have given a stream here. So this is uh methanol water. Okay, let me change the units to kgs per hour. The problem says, the problem says to solve, let me actually show you another screen also here where you can see the problem. Yeah, so double click here and then flow rate and composition is methanol 14,460 and water 10,440 kgs per hour. This is what I have entered as the inputs. And temperature, it said it is entered in the subcooled liquid. So temperature is, I am taking it as 20 degrees centigrade. So 20 plus 273 comes to 293 Kelvin. So pressure is 1 atmosphere. 1 atmosphere is equal to 101.325 kilopascals. So this is what my feed condition has been entered into this. So this is S1. And then I jump into this, shortcut distillation column. But I will definitely show it to you again how to actually do it. So I've removed it. Take the shortcut distillation column and try to place it here. It will ask me whether you require a condenser or a reboiler. So if you are not taking a condenser reboiler, it will act as a observer. Okay. Now I will connect this feed stream to at the something center, and then this stream to this particular outlet, and then this stream. Let me connect this stream to at the bottom. So here one caution is very important here. While connecting the stream at the top of the distillation column, that means condenser, you should be careful enough because you will be connecting. If I can take this, so this particular green color is shown as a water, but instead you should actually take this red color, which is actually a liquid. Okay, we are not interested in the separation of the water, but rather interested in the separation of the methanol. And in this particular scenario, what is that we are trying to look at is that there is something called methanol and water. Yes, I think you are all able to understand what I'm trying to say. So this problem is methanol and water. Okay, so this is methanol and water problem. So methanol is the high boiling liquid and water is a low boiling liquid. And you can see this name of the module is given as SCD1, that means shortcut distillation column 1. In this, it will not ask you. Now we have to enter. See, I have already entered the details here. Flow rate, individual flow. I have chosen not the total, but I have chosen individual component flow rates. Methanol is 14,460 and water is 10,440. Okay, done. Now let me open this because this is also red. I have to open the shortcut distillation. Condenser reboiler already set. Yeah. So it is given as bubble. Condenser is, that means it is total condenser. Now I go to minimum reflux ratio. Light key, that means which is more volatile, I consider it as methanol, and heavy key, I consider it as water. Now this R to minimum, R to R minimum reflux ratio, generally by default in a what you call design thumb rule, we can say it is around 1.8 to 2.5. Let me consider it as 2.5. So R to R minimum, I'm considering it to be as 2.5. So let me see. Now still there are there is red color specifications and product specifications. And specifications, see the top product is stream S2. I want in that composition and methanol to be as 0.99%. That means 99%. So I choose here 0.99%. At the same time, I want in the bottom, that means bottom stream is S3. In the bottom S3, I want methanol to be very less, but I consider it to be as around 0.1. That means I specify it as 10%, I specify it as 0.1. So products, this is something, F is equal to D plus W. F is feed and D is the distillate, W is the residue. You have to specify at least one because we know the feed composite, feed flow rate, but D and W, that means equation is one and we don't know two other variables means it does not start in numerical value. So let me take it as a mass because my initial feed contains 14,990. Let me see that 14,460 kg per hour methanol, and I'm saying 99%. Roughly around, I wish to take it around, suppose say 12,500 kgs per hour. This is an approximate value which we are trying to get. So all other things are blue here, and Penske estimates we don't have to bother now. Now let me say okay. Now the input given to this particular total process flow sheet window is done. We are done with the input. Now let me go to now the next part. I think thermodynamic model. I said in the problem thermodynamic model we have to choose this NRTL. First of all, let me delete this NRTL first so that it is easy for you. Now I want to add. See now the thermodynamic model, it is not there. Let me delete it. Delete and then okay. Now see red color. Then means thermodynamic model is not set because there is a water molecule. Generally we choose most commonly method and NRTL and add and then single liquid phase only and okay. And then because why single liquid phase? Because methanol water are soluble in completely soluble. You can say single liquid phase. Now you see here the units of measure also is very important. I have gone to this particular units of measure at the top, and then I said initialize this one, and then I have chosen SI metric system, and then I said okay, fine. So this is what I said. So my system is ready now. Now just let me actually restore the data and save. I have to click every time if I change any data. You please click restore input data. Otherwise, the previous results might actually recur and your simulation might go wrong. Now let me go to run button now. See now the program is run. That means if I'm able to see the blue color appearing in this particular process flow sheet window, that means every other data is correct, and then my simulation is run with the given conditions. I think you are able to understand what I'm trying to say. Now let us see in this particular output, right? This is output. S2 is the top product, S3 is the bottom product. In S2, what is my results? See, I have said 99% is my requirement, and it has given me 0.9899. Of course, still more we can actually understand what we do. So this is molar composition methanol, and this is given in kg moles per hour. But you have to check in even kgs per hour also. That also we have to explore. Okay, and the top temperature is also given as 337.79. So if I want to look at, see, if I want to look in mass results, go to this output, and then again let me open this, go to this S2 and then right click and view mass results, and you will get in other results called, now you can see 12,409, and the composition of the mass composition is 19%. It is giving us mass composition 19%, and this is 12,409, and molar composition also similarly 0.9899. So approximately around 2,500 is coming out as a total product, in which 12,409 is our methanol. Okay, but now the question is how many trays are required. So if I click on the distillation column, right click and then view results, now you can see this window. In this window you can see this is the entire results of the shortcut distillation column. If I come down, now you can see the results here. There is something called 8 trays, and R by R minimum. Where is the R by R minimum? R by R minimum 2.5. We have selected R by R minimum to be as 2.5. In that particular condition, what are the total trays required? 7. And what are the feed tray required? 5.67. That means 5.67. We cannot specify 5.67 in the rating calculations. So we approximately say it is around 6 or something, or you can say 5. But okay, this is the starting point which we have to actually consider, and then go ahead for the simulation operation. So this is what we need to understand, and this is the result we are obtaining from this particular shortcut distillation operation. Yeah, still more, at the bottom of the distillation column, okay, let us see the what are the inputs we have specified. See, this is what the inputs we have given: 14,460 methanol and 10,440 as a water. We have seen this, and this is the composition, mass composition, which is available. Total mass entry is 24,900 kgs per hour, and temperature is 293 Kelvin, right? 293 Kelvin. This is what we have done, right? And any more specific things we require? Yeah, I think we are done with this particular. Now I want to see a different view of the vertical process flow sheet window, in which how do I do that? Let me go to tools, not tools, view, and then toggle stream. So see, this is the toggle stream window wherein I can see at each place what is happening, right? So this is where we can actually see. And then tools, I want to actually write the text. Where do I write the text? Draw, and then draw. This is methanol water distillation. So you can see, so this is a methanol water distillation operation. Okay. So with this, I end this particular answer, and then what is the result we have obtained? So the result we have obtained, let us see the column here, and then view results. So these are the view results. So this is 7 feed tray, total trays are 7, and the feed tray would be 5.67 if the R to R minimum is 2.5. If the R to R minimum is 1.75, total trays would be 8, and the feed tray would be around 6.58. So this is what you should actually report as your output, and give an analysis according to that. And this is only shortcut distillation column, and you have to actually achieve more, and then you need to go ahead with the optimization also while simulating. So that is how you will be enhancing the results. Okay. Then take care, and then let us come to the I will go into the next question. There you can actually see the question and answer it. If you are unable to answer the question, you can come back and view. You can go to the other video and then view. Bye.